Okay, now let's have a look at fractions and rational functions. So, real quick, a reminder about how fractions work. If you're going to add two fractions, they must have the same denominator, a common denominator. And once they do, what you can do is you can add the numerator, the top part together, and keep the same denominator. So a over c plus b over c can be added. They have the same denominator. And so it will turn into a plus b all over c. Similarly, to subtract two fractions, they have to have the same denominator. So I have a over c minus b over c. I can subtract those, but I will subtract the numerators and keep the same denominator. If you're multiplying fractions, they don't have to have common anything. You just simply multiply the numerators and the denominators. This is a times c over b times c. If you're dividing fractions, this is often what we will say, keep, change, flip. You turn a division into a multiplication problem. You keep the first fraction as is. You change the operation from division to multiplication, and you multiply it by the reciprocal or the flip-flop of this fraction times d over c. So that ends up being a times d over b times c. Here are a few adding fractions. If I'm asked to add 1/2 plus 1/3, I need to find a common denominator, something that 2 and 3 can both divide into. 6 is probably the easiest one to go for. 2 can go into 6 and 3 can go into 6. So I'm going to change this into a 6. How do I do that? Well, I had to multiply the 2 times the 3. So that means I have to multiply the 1 by a 3. So my new numerator is 3 times 1. That's my adjusted numerator. And you can see that 3 over 6 can simplify to 1/2. All right, if I change 3 to a 6, I had to multiply it by a 2, and I have to multiply the numerator by a 2. So 2 over 6 is equivalent to 1/3. Now that they have the same denominator, I can add 3 plus 2, keep the same denominator. Similarly, I'm going to go for 28. 4 and 7 can both go into 28. 4 times 7, 3 times 7. This is 21. Why do we do that? Because 7 over 7 is a 1. And so effectively, we have multiplied 3/4 times the number 1. And that's the only thing we are ever allowed to multiply or divide something by, because it's the identity, right? So what can I multiply 1 over 7 by and not change it? Another 1. So the form of the one called a well-chosen one that I want here to get a 28 will be, I need a 4 here, so 4 over 4 is a 1, and that's legal. 1 times 4 is 4, 7 times 4 is 28. So, you can't have that, Rosie. Sorry. You can have this. You can chew on this. So, now that we make that adjustment, if we're subtracting, what is 21 minus 4? That's going to be 17 over 28. All right, what would you do if you had this situation? Well, you can take any whole number and make it a fraction, because we are always allowed to divide by 1. So now it's a fraction and a fraction. If I need a common denominator of 5, this first fraction has a 5. I do not change the numerator because I didn't change the denominator. But if I want this one to have a 5, I multiply by 5 over 5. 1 times 5 is 5. 6 times 5 is 30. Now I can take 2 plus negative 30, or negative 28 over 5. And so this is going to be my answer. Now, in the past, you probably have been fussed at if you did not change this into a mixed number. It is fine with me. There might be an occasion when we need a mixed number, but right now I'm fine with this improper fraction right there. Okay, let's go on. What if we have variables involved? How can we simplify these expressions? Well, it's very simple. This fraction bar means divided by. So we have 5x squared divided by 35x. So what I can do with the numbers, 5 can divide into 5 once and can divide into 35 7 times. 1x can go into x squared. 2x is 1 time. I have 1x left over. So in the numerator, I have 1 times x. In the denominator, I have 7 times 1. And this is what it simplifies down to. Number 2. 10 and 25, they both share a 5. So 5 goes into 10 2 times. 5 goes into 25 5 times. P squared goes into P squared once, and 2P squared will take away 2 of those. So I'm left with the 5 times P over a 2. Right here, you see these pluses? I'm not allowed to just divide anything I want to because they're not being multiplied. I have to factor it first. So what I'm going to do in the numerator is factor out an 8. That leaves me with a K plus 2. In the denominator, I'm going to factor out a 9, and that leaves me with a K plus 2. Now I have a multiplied 8 times K plus 2 over 9 times K plus 2. These common factors can divide into each other, giving me a 1. So this simplifies down to 8 over 9. Let's see. Over here, look at 4. Everything is being multiplied, and there's this common factor of t minus 15, which can divide into each other. We're left with a 2 over t plus 2. Now, look at 5. When you are dividing by a monomial, you are allowed a one-term polynomial. You can think of this as 4x cubed over 4x squared minus 8x squared over 4x squared. This will go into each term individually. So to simplify the first term, I'm left with simply an x. I wrote that down, x squared. And over here, I'm going to be left with, these will divide into each other, and this will give me a minus 2. To simplify number 7, what I'm going to have to do is factor the numerator. I'm going to factor this faster, just kind of quickly. I use the AC method, but this one I think I can see. This is m minus 2, m minus 2. I'm going to check that. M times m is m squared. Minus 2m minus 2m is minus 4m. Negative 2 times negative 2 is 4. Here I'm going to factor this into plus 3 minus 2. This is m squared plus m minus 6. So you can use the AC method like we talked about in the last video and get the same answer. But now that it's all factored, everybody's being multiplied, now I can divide common factors. This will be m minus 2 over m plus 3. Quickly, let's do 6. This is a monomial. It will divide into each one. So if I say 9 goes into 36 4 times, y goes into y squared 1 time, we'll get that. The 72y over 9y will just give me an 8. Here I have to factor and then cancel. So this factors into r minus 3, r plus 2. You can use the AC method to do this. This factors into r plus 4, r minus 3, and when you see me doing this, I'm checking it in my head, r squared plus r minus 12, so I agree. So this r minus 3 will cancel, and I'm left with r plus 2 over r plus 4. Okay, let's just do a couple of these down here. This is multiplying fractions, so you are allowed to just multiply across, but also, since everybody's being multiplied, if you see a common factor in the numerator, in the denominator, whether it's directly above and below the fraction bar or across, you can divide into it. For instance, 5 can go into 5 once and into 25 5 times. 3 can go into 3 once and into 9 3 times. One of these k's will knock out one of these k's. So this simplifies down to 3k over 5. Right here, let's do this. This is a division problem. So what we're going to do is a keep, change, flip. 15 p to the third over 9 p squared. Keep, change, flip times the reciprocal 10p squared over 6p. So watch this. Anything in the denominator can divide into anything in the numerator when it's being multiplied. So if I want to say this p can divide into this p squared 1 time, that's fine. If I want to say, oh, there's a 3 in this 6, and there's a 3 in this 15, 3 can go into 6 2 times. 3 can go into 15 5 times. If I want to try to reduce this further, I can say 2 can go into 2 once and into 10 5 times. If I see that this p squared can go into this p cubed, p times. I think that's everything I can get. I have a 5 times a 5 times a p, which is 25 p squared over 9. And if you want to take this in a few steps instead of just canceling it all at once, you are welcome to do that. So I think that's all I'm going to do on rational functions.